Hello again, guys. This is Matt Bay, aka Nhlakani Pungwane. So welcome to the channel again. So today we'll be doing, we're still on trigonometry. So we'll be doing a problem that falls under the category of 2Ds and 3D problems. We used to call it heights and distances. So I will give you tips on how to go about solving it. So it's the second problem on our series of basically solving problems on the trigonometry. So welcome to the channel. If you haven't subscribed, please subscribe, like, and leave comments, please. So let's get to it. Okay, guys. As I said, so today we are doing 2D and 3D problems. So we're still on trigonometry. So basically, okay. So this is our property. This is the diagram that sort of describes our problem today, and I will read the statement now. But I just want to say a few things about 3D problems. So when you have 3D problems, you should always think of elements of 2D problems, 2D trigonometric problems. So we're talking SOHCAHTOA, but that are combined together to form a 3D plane, to form a mathematical problem that is on the 3D plane, right? So that means whenever you're trying to solve it, you should always look for ways in which you can break it down to the normal 2D problem, so you can apply your SOHCAHTOA. So by SOHCAHTOA, I mean where you basically know that sine corresponds to opposite over hypotenuse, cos corresponds to adjacent over hypotenuse, and tan corresponds to adjacent over corresponds to opposite over adjacent. So whenever you're having a 3D problem, one of the best ways to deal with it is to basically break it down to your 2D problems, a 2D problem, and then basically identify which technique to use, which technique is best suited to use to solve the problem. So it can be your normal trig ratios, sine, cos, and tan, and their inverses, of course. And also you can also apply rules like the sine rule, the cosine rule, etc. Okay, so the problem that we are dealing with today says a vertical post PT. So that there is PT there. PT has its foot in the same horizontal plane as points Q and R. So points Q and R, this is point Q and this is point R here, right? So they are also saying TQ is equals to TR. So this is line TQ. They are saying this line is equals to TR, and they are both equals to Y. And then they are also saying line PQ. So that's line PQ is equals to line PR. This is line PR. And then they're saying the angle of elevation from Q to P is theta. So that's theta there, the angle of elevation from Q to P. And also they're saying angle PRQ, angle PRQ, angle PRQ. So this angle here, they are saying it's beta. Okay, so the first thing is to understand the statement, the problem statement, accurately. So when you do that, you've already solved 80% of the problem. So they are saying a vertical post PT. So in 3D problems, they will always say a vertical post, a vertical building, a vertical line. They are basically saying the line that is perpendicular to the surface. The line that when you draw from it on the surface, any line, the angle between the line that's on the surface and that vertical line will be 90 degrees, right? So our vertical post, our vertical line in this case is PT. So that means every line that's drawn from that vertex from point T is basically at 90 degrees with PT. That's the significance of the vertical point, and that's essentially what makes this problem a 3D problem. So that means your surface, as they said, consists of line TQ and line TR. Also, line QR is still on the surface, but I'm referring to lines that are in contact with line PT. Okay, and then another thing is that you must note every information that they've given you. So they're saying they're saying TQ is equals to TR equals to TY. So they are saying this line here TQ is equals to this line here TR. So you must note that. Maybe let's use a single dash to note that these lines are equal. And the moment you do that, you know that, okay, if you're talking about a triangle QTR, you already know that it's an isosceles triangle because you've got two lines that are equal. So that means the base angles of that triangle are equal. Maybe that we will use that at some point. And also another thing they're telling you is that line PQ, this line PQ is equals to line PR. Maybe let's note that using double dashes. So this line is equals to this line, right? So we also know that a triangle QPR is an isosceles triangle. That means base angles of that triangle are equal because line PQ, they've just told us that it's equal to line PR. Perhaps you can even indicate it with a different markup, but we'll use the same one here because that's what we have. You can indicate that a line, this angle RQP is also beta. It's equals to beta units, beta degrees, because we are given that PRQ is beta. So we know that the base angles of triangle QPR are equal because they've just told us that lines PQ and line PR are equal. So this is the information that we are marking straight away from just looking at the diagram. And you have solved the problem a great deal even before actually going to the question. So the first question says we are required to express PQ in terms of Y. Remember, line TQ is Y units and TR is also Y units in terms of Y and theta, right? Okay. So they they want us to write line PQ in terms of Y and theta, and by just looking at this, you need basically to isolate. You need to isolate a triangle that comprises of angle theta and that has line that is 1 unit long, y units long. Then when you isolate that triangle, and it must also have line PQ because line PQ is what we are looking for in 12.1. So when you isolate that triangle, you will basically simplify your problem. So and that triangle, we can see that it's triangle PTQ. So in solving 12.1, let's say consider triangle PTQ, and perhaps let's draw it. Okay, this is for demonstration purposes. In your when you're actually doing this for exam, you don't need to go through this pain in terms of drawing it, right? So we know that we have P there, we have T here, and then we have Q. So we've just isolated an element of this whole 3D diagram, PTQ, and we know that TQ is Y, and angle TQP is theta, and we are looking for line PQ. So our problem just became a normal SOHCAHTOA problem. Okay, since we can already see that PQ is the hypotenuse of triangle PTQ, and the line that we must use is TQ. So, and TQ is adjacent to angle theta. So when you're talking about angle theta, you've got two lines besides the hypotenuse. You've got the line that's opposite to it, PT, and you've got the line that's adjacent to it, TQ. So they've said we must try and write PQ in terms of y. So we're going to use the line that's adjacent to theta, and we're going to use the line that acts as the hypotenuse. So that means in terms of our trig ratios, we're going to use the cosine of theta. That is because we're using adjacent and the hypotenuse. So we can say, we'll say cos theta is equals to adjacent over hypotenuse. So the line that's adjacent to theta is TQ, and our hypotenuse, the line that is opposite 90 degrees, is PQ, right? And then we have to make PQ the subject of the formula. So you can just take PQ there and take cosine theta there. So PQ is equals to TQ over cosine theta. And we know that TQ is equals to y units. Y over cosine theta. So this is PQ, and this is PQ with respect to y and theta. So you know that in your solution you must have y and you must have theta. So perhaps we can also show how we cross multiplied there. So we had cos theta, or as a side note, cos theta equals to TQ over PQ, and you have cos theta over 1, and we cross multiplied. Then we had cos theta PQ equals to TQ times 1, which is also TQ, and then we divided by cos theta on both sides, divided by cos theta on both sides, and then we have PQ is equals to TQ all over cos theta. So this is how we ended up having PQ is equals to TQ over cos theta, and we recalled that TQ is equals to y units. So that's 12.1. So you must always bear in mind that 12.1 will most likely lead you to the next question, which is 12.2. Okay, so now we are on 12.2, and on 12.2 we are required to prove, so our question statement says prove that QR is equals to 2y cos beta over cos theta, right? So this is what we are required to prove, that QR is equals to 2y cos beta over cos theta. So we need to go back to our diagram, right? So in our diagram, this is line QR. This is line QR. So, and also in what we are required to prove, you can see that there's a y over cos theta, which is PQ. So it's more like they're saying, let us prove that QR is equals to 2 PQ cos beta. But now it's written in terms of y and theta, and also in terms of beta. So this is why I said question 12.1 will always lead you, or will most likely lead you to question 12.2, to the next question. So how does this help you? It helps you in terms of determining which triangle you're going to use in solving for QR. Remember, line QR falls in triangle QTR, right? But in triangle QTR, we don't have a PQ, as we've just noted that there's an element of y over cos theta, which is PQ in this problem. And also in triangle QTR, we don't have angle beta. Angle beta lies in triangle QPR. So this solves that ambiguity of which triangle are you going to use. So another triangle that line QR lies in is actually triangle QPR. And in triangle QPR, we have line PQ that's equals to y. We can just know y over cos theta. And also line PR, because they told us that line PR is equals to line PQ. So line PR is also 1 y over cos theta. And also we have angle beta still making up one of the angles that are in triangle QPR. So we can safely assume that the triangle to use in solving for QR is triangle QPR. And perhaps in order to simplify our things, we need to isolate that triangle. So that triangle is shaped like this, right? So we have P, we have Q, we have R. So it's more like a face of this 3D problem. So like I said, a 3D plane problem is a combination of many 2D problems, and that's what you do when you're solving. You have to try and isolate a 2D element of a 3D that will help you find your solution. Okay, so we know that this is PQ, that is y over cos theta, and this side is also equals to this side. PR, they told us that PR is also y over cos theta, and this angle here, angle PRQ, is given to be beta. So now what are we looking for? We are looking for line QR, right? So we need to determine which technique to use, which rule to use in order to find line QR. Whenever you are given only two lines that are enclosing an angle that you are also given, and they're asking you for the line that's opposite the angle that you are given, cosine rule is the most likely method to use there. And when you have a pair of a line and an angle, and you have the way of finding an angle, and you are looking for the line that's opposite to that angle that you can find, then sine rule will be the easiest way to use. So for our case, we can use both cosine rule and sine rule, because the fact that line PQ is equals to line PR means angle RQP is equals to beta, because it's the base angle of triangle QPR, and therefore we can easily get angle QPR, which is angle P, and then we can use the cosine rule to solve for line QR, and use line PQ and line PR that are enclosing angle QPR, but that will be very long. If we can find a way to get that angle there, angle QPR, so this angle here, we can therefore use this pair PQ and angle PRQ, so the angle that is beta, and then use this pair QR and that angle there to solve for line QR, and that is what we're going to do. So we're going to use the sine rule, but in our way towards using the sine rule, we first going to try and determine that angle there. So before we do that, we need to get angle RQP. So we can say angle RQP is equals to angle angle PRQ equals to beta. So we are basically saying this angle is equals to this angle over here. And then you must justify your statement. So we can simply say base angles often isosceles triangle. So with triangle QPR. So base angles of an isosceles triangle QPR, right? So that means angle RPQ is beta also. So this angle here is also beta. We can say that because line PQ is equals to line PR, right? So now our task is to find that angle, the angle QPR, and we're going to use the fact that the sum of angles inside a triangle is equals to 180 degrees. So we'll say angle PRQ plus angle RQP plus angle QPR is equals to 180 degrees. And we can just say sum of angles of triangle QPR. Sum of angles of triangle QPR is equals to 180 degrees. So remember that angle PRQ is given to be beta, right? And then we've just shown that angle RQP, which is this angle here, is also beta. So beta plus the angle that we are looking for. Angle QPR is equals to 180 degrees. So we can therefore straight away write that angle QPR is equals to 180 degrees minus 2 beta, because beta plus beta is 2 beta, and then when we transpose it, it changes the sign from being positive to being negative, right? So we have that angle there. We know that it's 180 degrees minus 2 beta. So now we will use the line angle pair that we have, PQ and angle PRQ, and also QR and angle QPR to find line QR. So we're going to use the sine rule, right? Okay. So when we use the sine rule, let's turn over the page. When we use the sine rule, okay, let me just draw the diagram here so that you'll be able to keep track of it quickly. Quickly. Okay, so this is Q, this is R, that's P there. We have just shown that this is beta, but we're going to write only the important angles. And then we've just shown that that's 180 degrees minus 2 beta. Then we have y over cos theta here. So we're looking for QR. So we're going to use the sine rule. You can actually use the cosine rule as well, but I think the sine rule will be easier. So we will put the lines as numerators because we are looking for QR, which is a line. So QR over sine, the angle that is opposite QR is angle QPR is equals to, can you notice that I'm not rushing into putting the actual units of the angle, the actual degrees. I'm first naming the angles and my lines. That's very important so that you don't get confused. And then this is equals to line PQ, line PQ over sine of angle PRQ. So you're using line PQ and the angle that's opposite line PQ, angle PRQ, right? So let's make QR the subject of the formula because it's what we are looking for. So we can just take this, because we are dividing and multiplying, and send it across there, like I showed you here. Okay, so we have QR is equals to PQ sine of angle QPR over a sine of angle PRQ, right? So okay, now when you have your problem like this is the time for you to substitute, because everything is nicely placed where you want it. So we had just proven that on question 12.1 that PQ is y over cos theta. So that's what we're going to put here. So we have y over cos theta, and then this is multiplied by sine of angle QPR. Angle QPR is what? Is 180 degrees minus 2 beta, right? So this is all over sine angle PRQ. Angle PRQ, it's beta, right? It's this. So all over sine angle sine beta, right? Okay, so this is QR. Okay, so when you have a fraction like this on the numerator, you can just take what's on the denominator of that fraction and put it below the division line. But let me show you why you can do that. So let's first take the numerator and write it like this: y over cos theta sine, this will be redundant for many, 180 degrees minus 2 beta, and then change. So it's important to do this when you are not sure about these things, so that you don't get confused. Then change this division line into this operator form, division like this, and then write sine beta, right? Sine beta. So this will help you not to confuse things. And then y cos theta, sine of 180 degrees minus 2 beta. Then you change this division sign into a multiplication sign, and this sine beta becomes 1 over sine beta, right? Then you have at the top you have y sine of 180 degrees minus 2 beta all over cos theta times sine beta, all over cos theta sine beta, right? Okay, so can you see that you could have just dropped that cos theta there, but if you are not experienced enough, you won't know when to do that and when not to do that. Okay, so let's deal with this compound angle now, because I've been bringing it along. Okay, so let's bring y as part of our numerator, and then let's handle this this compound angle with a special angle 180 degrees. So you must look at the trig ratio that you're talking about. So we are talking about sine, and then look at the special angle and the sine between the angles, right? So the special angle is 180 degrees, and the fact that we have minus, that means we have 180 degrees minus. So that means we are on the second quadrant when you have 180 degrees minus. So then you ask yourself, what is the sign of the trig ratio sine when you are on the second quadrant? It's positive, right? And also the fact that we are using a special angle 180 degrees, it means the trig ratio will not change. So that means we bring sine as it is, and then we write the angle 2 beta, right? 2 beta. And then all over cos theta sine beta. And then you remember, like we did on the first problem, you remember as a side note that sine 2 beta is equals to 2 sine beta cos beta, right? And then we write that on our numerator, so we have y into 2 sine beta cos beta all over cos theta into sine beta, right? And because we are multiplying and dividing, we can cancel what needs to be cancelled. So we can see that we can spot the sine beta and the sine beta on both the numerator and the denominator, so that goes away. And then we have 2 on the numerator, we have 2y cos beta all over cos theta. Remember, this is equals to QR. So we have shown that QR is equals to 2y cos beta over cos theta, and I hope that was not difficult. Okay, so this is how you go about solving this problem. I hope you took all the tips that I gave you. Okay guys, don't forget to subscribe, don't forget to like, and don't forget to comment on these videos. Thank you so much. If you have any questions, please feel free to ask, and also comment on how I'm explaining. Yeah, thank you so much. Bye.